Hello everyone. So far we have discussed the structure and stability of colloids as well as the preparation methods of colloids, in which you have discussed the dispersion methods. So now we have to move on to the condensation methods. We have already covered the 4 dispersion methods. So let's start the condensation methods for the preparation of colloids. The first method is double decomposition. This method is used for the preparation of water insoluble salts. Example, a salt of yellow colored arsenious sulfide is prepared by passing hydrogen sulfide gas through a dilute solution of arsenious oxide and removing the excess hydrogen sulfide by boiling. The reaction is given here. Arsenious oxide plus H2S gives arsenious sulfide and water. So this reaction is very simple, wherein you are preparing a colloidal solution of arsenious sulfide. Simply we are passing hydrogen sulfide through an aqueous solution of arsenious oxide. We are obtaining the salt of arsenious sulfide and water. Here the decomposition of both arsenious oxide and hydrogen sulfide occurs, hence the name double decomposition. So this reaction is termed double decomposition since both the substrate, that is arsenious oxide, and the reagent, that is hydrogen sulfide, are getting decomposed. That is double decomposition. The next method is oxidation. Salts of non-metals are prepared by this method. Example, colloidal sulfur is prepared by oxidizing an aqueous solution of hydrogen sulfide with air or sulfur dioxide. So this example is pretty much simple, wherein we are preparing colloidal sulfur by oxidizing it by means of air or sulfur dioxide. So oxidizing an aqueous solution of hydrogen sulfide gives us sulfur salt plus water. So that is the reaction. The next method is reduction. Salts of metals like gold, silver, platinum are prepared by reducing the aqueous solution of their salts by non-electrolytes like formaldehyde, phenylhydrazine, etc. Hope you guys recall we have prepared the salt of gold, silver, platinum by another method in the dispersion section, that is Bradig's arc method, electrical dispersion. So that is an example for a dispersion method in which we are preparing the salt of these metals. And now we are going to learn a condensation method for the preparation of these metals. Example, preparation of gold salt by the reduction of auric chloride by formaldehyde. See, we are reducing the chloride of gold, that is auric chloride, using formaldehyde to obtain the salt of gold as well as HCl and formic acid as byproducts. So here we are using the reagent, an organic reagent, that is non-electrolytes like formaldehyde, phenylhydrazine, etc. The gold salt is popularly known as purple of Cassius. The next method is hydrolysis. Salts of metal hydroxides can be prepared by this method. Example, when a small amount of ferric chloride is added to boiling water, a red-brown salt of ferric hydroxide is obtained. The reaction is given here. Ferric chloride plus water gives ferric hydroxide as well as HCl. Boiling promotes the reaction by removing the HCl formed along with water vapors. So we are boiling, we are making use of heat energy to expel this side products, so that boiling is promoting the reaction. So hydrolysis, that is addition of water, we are employing this method for the preparation of salts of metal hydroxides. So here I have taken a corresponding metal electrolyte and I am adding water to it, and we are obtaining the corresponding metal hydroxide salt. That is the reaction. And the last method in the preparation of colloids is exchange of solvents. This method is used for the preparation of colloids of phosphorus and sulfur. Both phosphorus and sulfur are insoluble in water. So, when an alcoholic solution of sulfur is poured into boiling water, the alcohol evaporates, leaving behind sulfur particles that eventually leads to sulfur salt formation. So this reaction is very simple to comprehend. I will demonstrate the reaction in here. See, I have taken boiling water. Assume that this is boiling water. What I am doing is that I am adding an alcoholic solution of sulfur to this mixture, that is to this boiling water. So I am adding alcoholic solution of sulfur or phosphorus. What happens is that the alcohol, after reaching this boiling water, it gets evaporated. Why? Because we know that alcohols are more volatile compared to water, so they easily gets evaporated. Then what remains in this solution is sulfur, thus forming sulfur salt. So that is the reaction. Sulfur in alcohol plus water gives sulfur salt, and phosphorus in alcohol plus water similarly gives phosphorus salt. So this reaction is exchange of solvent, because actually we are making use of two solvents, water and alcohol. So firstly we had alcohol which is acting as a solvent, but after the process we are getting sulfur in water, salt. So that is why this is known as exchange of solvents. Now that we have completed learning different preparation methods of colloids, have some fun here. You can prepare these colloids at your home. Some examples that you can try out are mayonnaise, which is an emulsion of oil and egg, butter, whipped cream, gelatin, jelly, muddy water, cornstarch dissolved in water, glue made up of refined wheat flour and water. Next we have the classification of colloids. There is nothing more to discuss about this, because simply this is the preparation of, this is the classification of colloids based on the dispersed phase and dispersion medium. That is, if the dispersed phase is gas and the dispersion medium is liquid, that colloidal system is called foam or froth, and some examples are soap foam, whipped cream, etc. Similarly, we have different dispersed phases and dispersion medium as well as some examples. So please go through this. You can refer to this as well, wherein I have given the dispersed phase horizontally and the dispersion medium vertically. And gas-gas colloidal system does not exist, because all gases are mutually miscible, so they do not form any sort of colloid, because mixture of gases usually form homogeneous mixtures or solutions. Then you can see gas liquid colloidal system, gas solid colloidal system. So please read this as well. Thank you.